This is a pretty comprehensive question. It says, what can you tell about the combustion of ethanol from the information that the change in enthalpy of combustion of ethanol is negative 1.21 kilojoule per mole? That says a lot. But what I can tell from that is, first of all, that this is an exothermic change. So combustion of ethanol is exothermic. Now, because I know it's exothermic, I know its potential energy is decreasing so that the reactants have higher potential energy than the products, because this enthalpy is a negative value. So we've got energy that is being given off from the chemical potential energy and converted to kinetic energy that we will see and experience, where the change in temperature, the temperature is increasing. So we get more kinetic energy of the calorimeter because of this energy change that is exothermic. If it is an exothermic change and potential energy decreases, then if the EP decreases, so potential energy decreases, and energy is being given off, more bond energy is made than broken. Then bonds are broken. Because remember that it takes energy to break bonds, and when we make bonds, we get energy back. So if the energy is being given off, we must be making more bonds that give away energy than we have broken. So the endothermic and exothermic change, we know it's exothermic. Kinetic energy is going up because it's exothermic. So the delta T, we measure that. The calorimeter is going to warm up. So we know more bonds are being made than broken. And from this, we could calculate, because we know the delta combustion enthalpy for ethanol is negative 1.21 kilojoule per mole. If I could find the number of moles of ethanol, then I could calculate the energy that's released. So that would be number of moles could be mass divided by molar mass. That seems like the most likely way to calculate it. Then I can calculate the energy, because N delta H equals Q. And if I knew the calorimeter's mass of water, then I could also calculate the delta T, because these two things would be known. If I had the number of moles of ethanol and I know its specific heat capacity, I can calculate the Q. And if I knew the mass and the specific heat capacity of the calorimeter, I could calculate that delta T. So there's quite a bit of information that can be held in a molar enthalpy statement.